Hi everybody, this is Ryan. I'm here for a video. This time I'm going to talk about section 1.5, other types of equations. So in this section, we're going to talk about radical equations. And the reason I call them radical equations is because they have a radical symbol. We're also going to talk a little bit about absolute equations, and those have the absolute value symbols. And then we're going to talk about factorable polynomials. These are going to be ones that have a degree larger than 2. When I say degree larger than 2, what I mean is this. So typically a second degree equation looks like this. Notice how the power right there is a 2. We're going to be talking about ones that are equations that are larger than 2, like x to the third or x to the fourth. So let's get started. Solving radical equations. First step is to isolate the radical. The second step is to raise both sides to appropriate power. If there's a square root, square both sides. If there's a cube, cube both sides. So remember, a square root and a square are opposites, or inverses. A cube and a cube root are inverses of one another. Solve the resulting equation using appropriate methods. You must do a complete numerical check or graphical step. Step 2 may introduce extraneous solutions that work after step 2 but not on the original equation. So here's an example. Let's take a look at this example. So the first step is to isolate your radical. So they isolated the square root on the left side. Now you have a square root. The inverse of a square root is a square. So we're going to square both sides. Notice what that does. That essentially removes the radical symbol. And if you have the quantity x minus 2 squared, you multiply that together and you get 12x minus 2x equals x squared minus 4x plus 4. And then at this point, you should know how to solve this equation. So we're going to collect like terms and move things around. So we're going to get down to where we have 0 equals x squared minus 2x minus 8, and we're going to factor that. So we get down to where we have two answers, x equals 4 and x equals negative 2. Now, with all of these equations, you've got to check your answers because sometimes you're going to produce an extraneous root, a root that shows the solution as a solution, but it doesn't work in the original equation. So you have to plug these back in. And in this case, you get down to 6 equals negative 2, and that is false. That can't happen. So that means you have to cross out x equals negative 2, so the only solution is x equals 4. Now, absolute values look like this. We're going to solve an absolute value equation. The way that I do them is I isolate the absolute value like this. And then what I do is I will use the definition that we showed up here. So there's two values, either x is negative or x is positive. So what we do is we write the answer as, you write the equation as 3x minus 2 equals 10. That's the positive side. And then we write the opposite of that. We write the negative of 3 minus 2x equals 10. Now sometimes we write it like this, and I actually prefer just doing this. Instead of making the part in the radical negative, I tend to skip a step and do 3x minus 2x. 3 minus 2x equal to negative 10. So I skip a step here. I do this instead of this step right here. So I wouldn't do this. I would do this, and then I would subtract 3. So I would get negative 2x equals negative 13. Divide by negative 2. So x is 13 over 2. So you get the same answer. And I recommend you check these. So the only change I would make to this is I wouldn't necessarily do it this way. I prefer to make the right part the negative. So again, on this one, if I was doing this, and I necessarily wouldn't do way 2. You can look at that if you want to, but I would do 7x minus 11 equals 6. And I would do or 7x minus 11 equals negative 6. Those are the ways that I would solve the equations, and solve both of those to get your answers. Now, factorable polynomials. So this time, You're going to need to think, the key to these is, remember, x to the fourth is equal to x squared times x squared. So that's the little trick here. You have to understand that x squared times x squared is x to the fourth. So then you basically what you're basically doing is you're basically factoring this equation right here. You're basically factoring this equation right here, which we know how to factor that. But instead of the x squared, you have x to the fourth. It's right here. So you just make x, instead of having x times x right here, these two x's, you have x squared and x squared. Because in this case, x times x is x squared. In this case up here, x squared times x squared is x to the fourth. So it's exactly the same problem, except for you're just dealing with a x to the fourth instead of x squared. And the problem, it works out exactly the same. Again, on this one, the trick here on this one is we're using a technique called use substitution, but the same thing holds. X to the third times x to the third equals x to the sixth. So it's the same exact thing, except for in this case, they're letting u equal x to the third, because u squared equals x to the third squared, or x to the sixth. So you can just substitute then, wherever you see an x to the sixth, you can put u squared. So then you're working down to u squared minus 7u minus 8 equals 0. And it's a much easier problem to factor. And then you could just do it the simple way like this. And then the last way would be to just use a quadratic formula. So in this case, you can factor them down, and then you can use a quadratic formula to solve each side. Hope this video helped you. If you have questions, please let me know. Thanks a lot.